Hi students, this is Mr. Werman here. So we're going to go through a lesson here from lesson 4, chapter 4 in your textbooks. So I want you all to follow along. You should have headphones in, pencil out, follow along in your books. If you don't have your books, then do just follow along with paper, okay? So today what we're going to do is talk about linear functions and graphing those, okay? We have been doing linear functions for over a week now, right? We see, example of a equation listed here, which is basically a linear function, y equals 36.6x, okay? But that's typically what our linear function is. We have our y and x. Our x, again, could be another word for domain. Our y is our range. We might also say f of x instead of y, okay? But they're all kind of that same thing. Where we have our equation. We'll often put it into a table. We'll use those tables to create coordinates, right? Ordered pairs like this here. And then we'll graph those on graphs, okay? And just remembering they're just representing them in all these different ways, okay? So we're going to just model these relationships in different ways, okay? All right. So I'll try to be quick so this video doesn't get too long. All right, graphing a function. So sometimes functions are written using two variables, as we said. One variable is x, usually the domain, or sometimes we call that the independent variable. The other y, or f of x, and that's the range, and we'll often call that the dependent variable. And then when we write those functions, we can create those into equations. Like equations, functions can be represented in words, table, graph, and ordered pairs. Okay, so let's look at this quick example here. So they give us a brief example. This is on page 296 in the book. So if you haven't done so already, we are on chapter 4, lesson 4. That's page 296 now. Okay, so the example they give us, we have an equation here, y equals 5 minus 2x. This equation represents the situation. Basically, Tony has $5 to spend. Their book covers are $2 each. Notebooks are $1 each. So we know 2 times x, $2 for each notebook is 2x, and $2 for each book cover being x, notebook being y. So we know in this situation, if Tony has $5 to spend and she spends $2 per book cover, we can see how much money she has left for her notebooks. Okay, so we could take this equation that we have here. We could break it down into a table as they've done. We have x, this 5 minus 2x, and the y. So for each of these x's, they chose 0 through 3 and labeled our table as such. For each x, we just substituted that 0, right? So 5 minus 2 times 0 is 5 minus 0, which is 5. We substituted the 1 here. 2 times 1 being a 2, 5 minus 2 being 3. Okay. 5 minus 2 times 2, 5 minus 4 equaling 1. All right. And 5 minus 2 times 3 being 6 is negative 1, right? We cannot have, of course, a negative 1 money for notebooks. So that one would be an impossible thing to do. And we can see that with the graph. All the rest of these are in our first quadrant. We have our points labeled 0, 5, 0, 5. 1, 3, 1, 3, right? 2, 1, 2, 1. All right. And so we have a graph like so. Okay, those are all the possibilities for Tony to buy books at the bookstore. Okay, let's look at another one real quick here, okay? So it says the farmer's market sells, okay, the farmer's market sells apples for $2 a pound and oranges for $1 a pound. And Margie has $10 to spend. So here's our equation. We have $10, and then since apples are $2 per pound, we have x representing the apples, y representing the oranges. Okay, so let us create a little table for this. Okay. All right. So, all right. So we have our equation. So I want you all to create this table as well. We're going to have, actually, I'll do this here. We're going to have a x on this side. In the middle of our table, we'll have 10 minus 2x. And then that is, of course, going to equal our range, which is y. These little lines through here so it looks nice and neat. Okay. Great. So for our equation here, let's choose some different numbers to write in here. So let's first plug in a 1 for x. Okay. So since we know it's x, all we're doing is substituting that number right there, that variable x, for that number 1. So go down here a little bit and make this a little smaller so we can fit it all in. So let's just say 10 minus 2 times 1. So 10 minus 2 essentially, 2 times 1 being 2, is of course equal to 8. Okay. Let's say skip 0. I'm going to do 0 as well. Let's do 0. And then we have 10 minus 2 times 0. 2 times 0 being 0. So it ends up just being 10 for y. I'm going to do let's say a 2. So we have 10 minus 2 times the quantity of 2. 2 times 2 being 4. 10 minus 4 being 6. Okay, and maybe one more. Let's go with 3. And we have 10 minus 2 times 3. Okay. 2 times 3 being 6. So 6 versus 4. Okay, so we've just plugged multiple values, 4 different values, into this function here to figure out what our x's and our y's are. All right, so now I will go ahead and plot those on the graph. So we have our equation again, we have our table, and from this table we can extract now our ordered pairs to plot our coordinates on our graph. So I'll do the first one there, 1 over 8. Notice these go up by 2, so 1 is going to be right in the middle, 8 is right here. See if we can get that to work. Make that a little bigger. 1, 8. That'll work. Then we have 0 over and 10 up. Okay, great. We have 2 over 6 up. And then our last one is 3 over, right between 2 and 4, and 4 up. Okay. So we can connect those now with a straight line. Make a thinner line here. Start that one. Okay, great. And there we have it. We have our graph. So we have this situation represented again. Equation, ordered pairs in the table, graph. We can look at the graph. It says graph the function and interpret the points graphed. One thing we notice when, I'm sorry, who loves to do this? When we have there we go. Sorry. When we have our 0 over 10 up, right? So in other words, when we spend $0 or we buy 0 pounds of apples, we can get 10 pounds of oranges, right? When we spend 2 pounds, buy 2 pounds of apples, we can get 6 pounds of oranges, right? And lastly here, we can go all the way here and say when we spend $5, sorry, we buy 5 pounds of apples, it would be $10. We'd have 0 left for oranges, all right? Because that's at that point is 5 over 0 up, all right? So we can plot it, we can read it, etc. All right, let's look at another one. Hopefully we got that down. If not, you can rewind the video a second, go back a second to finish that there. Okay. So this is just another example of the same concept, okay? We've got a graphed 0 plus 2. So we have our equation, x plus 2. So we have 0, plug in our 0, 0 plus 2 is 2. Our coordinate 0, 2. 1, 1 plus 2, 3. So our coordinate 1, 3. Okay, and then etc. We graph it, plot it like so. All right, look at another one here. Just like the last ones, this one's not a story problem. Pretty simple here. All we are doing once again is making a little table to plot this out. All right. So we have our same thing here. Make this nice and big here. I'm going to put it up top on this corner. So find a spot to put this on your page. So you have x, and then we have x minus 5. And then we have our y. Okay, again, you should be following along with this in your book. Okay, it's a little tight in there, but that should work. All right, so we'll just try a couple different numbers here. All right, so x, let's try 0. So if we put that in the equation, we have 0 minus 5. What's 0 minus 5? Okay. Another number, 1. We have 1 minus 5, which of course is 4. I'll say 3. So we have 3 minus 5. 2. I'll just go ahead and do 5 real quick too. 5. 5 minus 5 being 0. Okay, so you should do at least 3, but I would say 4 is more comfortable number of coordinates there. So again, we have our equation here. This is function. We have it written in a table. In the table, we have written out the different coordinate pairs. So we'll go ahead and graph those coordinate pairs. We have 0, negative 5, right? So x is 0. So we have 0 over, negative 5 down. I'm not going to label each point on here. We can understand each cross line here represents 1. So don't bother labeling them. Just realize those could be 1. Okay, so 0, negative 5. So we got 0 over, negative 5 down. So 1, 2, 3, 4, 5. Boom. Great. The next one, 1 over, 4 down. Next one, 3 over, 1, 2, 3. And then I go 2 down, 1, 2. And then we have 5 over, so it's 3, 4, 5, and 0. Okay, so there we have our points plotted. We can connect those with a straight line. Go from here to there, like so. Okay, so we've got all of our coordinates, table plotted out. Okay, do the same thing for this, right? You put a 1 in, you get out a negative 2. Okay, put a 2 in, you get out a negative 4. Okay, I'm not going to do that one for time's sake. Okay, great. Let's look at a little bit more here. All right, so as we said, representing functions, equation, ordered pairs, table, graph. That's what we're all about here, okay? So these linear functions are the ones that are going to form the straight line, okay? All right, and okay, this one thing up there. Okay, great. So let's look at a couple more of these here. Okay, so it says we should be about page 298. I don't have it in front of me, but that's about where we should be at. Okay, each person that enters a store receives a coupon for $5 off his entire purchase. Write a function to represent the total value of the coupons given out. So, so everyone gets receives a coupon for $5 off her purchase. Okay, so it says write a function to represent the total value of the coupons given out. So we're looking at the value of the coupons given out. Well, what is each coupon worth? $5, right? So if you have one coupon, it's worth $5. If you'd have 2 coupons, it'd be worth 2 times 5 being $10. So on and so forth. So it says our equation is y equals 5x. X representing the number of people that get this coupon, right? Okay. Y represents the total value of those coupons. Y equals 5x. So we put this into our table. X, Y, right? Domain, range. So our domain, this is make a table for 5, 10, 15, and 20, like so. We just plug all those in. Again, we're just substituting our x into this equation to get our y. Okay, 5 times 5, 25. 5 times 10 being 50, etc. Okay, all right. Once we have that, we can graph it as we see here. So we got 5 over 25, right? 10 over 50. Okay. Okay. So it talks about that in this case, right? This function is discrete. Something I flew over really quick here. but that each of these points, right, it's not necessarily a line that would connect them, right, because you can only have kind of whole numbers here, not every point in between, right? You can have half a customer or something, but we just have it plotted for 5, 10, 15, and 20 people, okay? All right. All right, so let's look at one more here, and that'll probably be good. So a store sells nuts for $5.95 a pound. Write a function to represent the total cost of any number of pounds of nuts. So if it's $5.95 per pound, what would be our equation? Well, if it's per pound, whenever you see that word per, always remember that probably indicates multiplication. All right. Again, if I'm going too fast, I'm trying to go fast for time's sake, but just slow the video down, pause it, rewind it. Okay. So we're going to write a function here. We'll use the y equals, and what do we have here? We say 5.95 per pound. So we'll say 595x. Right? Makes sense? 5.95 per pound. Right? So write a function to represent the total cost of any number of pounds of nuts. So no matter how many nuts you buy, you put it in this equation, and you get your y. All right, so this is kind of one of those real world things. In the real world, for all your stuff, if you're on a candy shop or anything where you're selling stuff by the pound, you'd have these types of equations in your cash registers and things like that. Okay, so we have x there. We put 5.95x there, and then our y there. Okay, so let's do this for 1, 2, 3, 4, and 5. So I'll just write it down here. 1, come in, 2, 3, 4, and 5. Okay, so just plugging it into the equation, we would just write 5.95 times 1. 5. Again, as I've said throughout this unit, make sure you got a calculator. It's going to help you a lot. We have 595 times 2, so that should be $11.90. We have 595, 3. Got that wrong, but okay. And so that'd be 17. 5, am I wrong? Okay. All right. For time's sake, I'll just stop there. Or I'll just maybe write this real quick here. 595 times 4. 23, you'd get 23.8. Remember, since we're dealing in dollars, 80, right? And then the last one here, 595 times 5, 29.75. So go ahead and plot some of these over here. So again, we have our function. Ta-da! We've got our table, and now we graph it. That's all we're doing, right? So x represents the, you could say the number of pounds. You could just say pounds. Our y here, that's our cost or price. So I'll just write cost. I can't write it that way, so I'll just write it there. This goes right here. Okay. And then lastly, plotting our points. All right. Get nice and big. So at 1, we have about 6. So we're going to go just above the 5, right? Okay. At 2, we have about 12. So we're going to go just above the 10. At 3, we have about 18. 18. 4, we have about 24. Just under the 25. And 5, we have just under 30. Barely under 30, basically 30. Okay, like so. Okay. So we've graphed it. Is it continuous or discrete? Well, this would be continuous because you could buy half a pound of nuts. If it was discrete, that would be impossible. But here, yes, you could buy half a pound of nuts. So we could connect it with a straight line if we so wanted, because we're talking about all those numbers in between as well. Okay, like so. All right, kind of making sense, hopefully. If you guys have questions, you can let me know. But hopefully you follow along with these. These should be completed in your book. You can always send me an email. Need a little extra help, but you should have watched this video first before you ask for extra help. Okay, that's all. All right, have a good day, you all. I will talk to you soon.